This is our first video presentation for hyperbola. So we shall define a hyperbola. We shall illustrate the essential characteristics of the points that lie in your hyperbola. And along the way, we shall also enumerate the important geometric objects in relation to your hyperbola. So a hyperbola is a set of points in a plane such that the difference of the distances of each point from two fixed points, the foci, is constant. So let us illustrate this definition through your graph. So this is our hyperbola, one whose principal axis is horizontal. So let us pick any point along the curve. Let's say, for example, point P. P has a distance from one focus. So that would be the length of the line segment F1P. And P also has a distance from the other focus, F2. So if we were to get the difference between these two distances, what we shall do is we shall get the length of this line segment minus the length of that line segment. Let's call that difference D, as in a delta. Now let us pick another point. Let's say a point that lies in the other branch of your hyperbola. So this one has a distance from F2, which is your focus, one focus. It also has a distance from F1. The difference between these two distances, or the absolute difference, is also D. So that is the essence of this definition. If you're using my book, you have there some sketches of the graph of a hyperbola. I was using GeoGebra, the same application software that I am using in my video presentation. But I did not know all the functionalities of GeoGebra. It's only now that I get to discover that you can actually get the length of the line segments. So I plotted these points in your plane using GeoGebra, and I got the length of the line segments. From P to F2 is 9.37. From P to F1 is 3.37. So if we were to get the difference of the two distances or the two line segments, the difference is 6. So how about when the point lies in the other branch of your hyperbola, a point which is not P? Well, the distance of A from F2 is 2.72. The distance of A from F1 is 8.72. Well, let us get their difference. Their difference, or the absolute difference, is also 6. So what we shall do now is identify the important parts of your hyperbola and other segments and points that arise in relation to your hyperbola. So this one is a hyperbola with center at the origin. A hyperbola has two branches. So you call this the branches. You have the vertices, so V1 and V2 are the vertices. And the line segment that connects those two vertices, you call that your transverse axis. So this is your transverse axis. Now you also have your foci. These are the fixed points that was spoken about in the definition, F1 and F2. So your principal axis goes through the focus or goes through the foci and the vertices. So that line there is your principal axis. And just like with your ellipse, your principal axis can be horizontal, it can be vertical. B1, B2, the line segment connecting B1 and B2 is your conjugate axis. So maybe you can still recall your ellipse. If this were your ellipse, this one would be your minor axis and this one would be your major axis. But for a hyperbola, we call that the conjugate axis. What else? So your hyperbola has a center that is the midpoint of your transverse axis and your conjugate axis. So the conjugate axis and the transverse axis, they meet at the center. Although in this example, our center is at the origin. We also have this thing called the latus rectum. Going back to your parabola, your latus rectum is telling you the focal width of your parabola. We also had the latus rectum in ellipse. So the same thing goes with your hyperbola. The latus rectum, which is a line segment passing through the focus and whose endpoints lie in your hyperbola. The latus rectum is perpendicular to your principal axis. So the latus rectum, just like in your parabola and ellipse, is telling you the focal width of your curve. But then again, going back to our ellipse, we did not use the latus rectum to help us sketch the graph of your ellipse. What we did was, we located the vertices and the endpoints of your minor axis, and then we traced a curve through those points. We shall do the same thing here, okay? We shall do the same thing here. We shall only plot the points, the vertices, and the endpoints of your conjugate axis, and we shall use them to help us trace the curves of your hyperbola. But your teachers might insist on using the latus rectum. If that is how your teachers prefer to do it, that would be fine. Okay, but for me, I am skipping the latus rectum when tracing the graph of a hyperbola, because if I were to do that, it requires a lot of information. I'm going to dump so much information to my students, and by the time we get to the latus rectum, my students might no longer be interested to graph the hyperbola. So that was my decision. So again, in this video and in the succeeding videos, when we sketch the graph of your hyperbola, we will pay attention only to the transverse axis and conjugate axis.